Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I am John Calloway.
I'm Clayton Hunt.
And I'm John Nash.
This week we're going to talk about the differences. This week we're going to talk about differences and perceptions around the quality of software and the grade of software. Ash, you want to explain a little bit?
Yeah, so I guess I could start off with a little bit of a story. Earlier this week was the beginning here in the United States for March Madness. Many people know that. So my company, they had hosted a happy hour event to celebrate this, and like good nerds, we quickly broke down into not watching the games and instead arguing about development practices and whatnot. So I got into a discussion with my coworkers about what software quality was, and sort of where it was not. So and there seemed to be an idea that the quality of the software is really strictly related to the fulfillment of the requirements. And one gentleman suggested that Bud Light is a high quality beer because it is one of the most vastly produced beers, and it adheres to the qualities and the standards that they have kind of put forth. So I took a little issue to that, and mostly he suggested that I was conflating the idea of quality versus grade, but I suggested that once you come up with the idea that the word high is a terminology that sort of allows you to grade something that you're talking about a grade. So anyways, I thought it might be kind of interesting for us to take a look and dig a little deeper into the subject and look at sort of what does some standards organizations talk about quality, what does it really mean to grade things, and sort of how does other engineering disciplines have to deal with these issues, and then how can we apply those things to better understand where we are as developers, where the business is, where the project managers, and what everyone's trying to get out of things.
Yeah, that's interesting. So I guess depending on your direction or your vantage point, your viewpoint, the quality could have a different definition. But I think certainly we can all agree that whether a house or an office building meets the requirement of so many number of rooms might fulfill that quality requirement or that requirement specifically. But if it has a cracked or broken foundation and it's going to fall apart in a year, then I don't think we would agree that is a quality building.
Yeah. So I guess the question is that included in, that's part of the, I guess, what would be, what many people would argue is that the requirement for the building to have a foundation or a solid foundation that lasts for so long would be a part of the implied needs and applied requirements of that building, even if it's not expressly expressed, I guess, for lack of vocabulary. So one things I thought would be interesting is look at the actual definitions that so the PMBOK uses, which is the project management body of knowledge. So version 5 says quality is the degree to which a set of inherent characteristics fulfills requirements. And then also another organization, the ISO, which is the International Standards Organization, they also have a definition of quality, in which quality is the totality of features and characteristics of a product or service that bear on its ability to satisfy stated or implied needs. And so I kind of looking at both of these things, I think if you were to try to simplify that language, the way that I really interpret that is, what they're both saying is quality is the fulfillment of the requirements.
So is that where it falls apart then in our discipline, that oftentimes those requirements aren't necessarily explicitly stated, and so we aren't seen as working towards those requirements, or maybe we're working towards an unknown set of requirements, or we're doing additional work that wasn't stated.
Yeah, I think there's a little bit of both to that. I think that ultimately what we can understand is that a lot of times there's a particular type of requirements that is very much unstated. I mean, sometimes we have both kinds of requirements, lots of types of requirements that are not stated. But if we do get any sort of requirement, hopefully those requirements are sort of written with the functionality and the value of the software, and sort of from the user's perspective, right? What are they going to be able to get out of it? And so if we look at what is the product that what is the product that the software is, sort of the value that we get when we're all after we've deployed it and the user's using it, and we can look at how does that product fulfill those requirements. That's really just a pass-fail question. Did it meet the requirements that we specified, and sometimes that the users did not specify or sort of were implied, or did it not? But there's another set of requirements that are really specific to more the business that is writing the software, and that is, can we create this? Can we continue to maintain it? Is it going to be profitable for us to be able to keep changing the software, or to change it, or to keep it running? And those are important requirements, but they're often going unstated. So I kind of thought maybe it might be good to talk about these two requirements in the software products requirements category and the software process requirements category.
So I feel like I kind of want to disagree with these standards bodies.
Well, that seems appropriate for you.
Yeah. So to me, you can 100% meet the requirements and be of really low quality. I mean, like quality is the thing that makes it right. You can have an application that's Battleship Gray and isn't very user friendly, but it's met all the requirements. So by their definition, it meets all the needs and it satisfies all the requirements. But it's low quality. Nobody actually wants to use it. Like, quality is that polish that gets put on by a really good UX individual, or in the case of the code, to your point, someone who is taking the time to make sure that the code will continue to function and be maintainable for the company. Like, that's not actually part of the requirement. The company's never going to ask you to write maintainable code, or they might imply it, but they don't ask it directly. It's not like, when you fulfill this requirement, make sure that we can go back and change it later.
Right. So I think this is a pretty good issue that you bring up, and I think this is where the idea of grading comes into play here. So PMBOK actually they give a definition for grade, and they say a grade is a category of or rank used to distinguish items that have the same functional use, do not share the same requirements for quality. So what you're describing, and sort of what PMBOK is saying you're describing, is you're describing software, one set of software, or two sets of software, right? The gray Battleship, bad UX, and the other one that has the good UX, right? Both of them share the same functional use, but one shares a higher level, is sort of adheres to a more strict set of requirements. So I kind of put to kind of reword their definition. I use the definition: grade ranks items by the strictest set of requirements they fulfill. So it's not talking about so much what your requirements were, but what could have your requirements been. So when we look at one particular software, we might say it's a low grade software, and therefore it may meet all of the requirements, but it's still a low grade of quality. And
see, now we're crossing the streams.
How do you figure?
Well, if quality and grade are different, then you can't be a grade of quality.
So this is where I also differentiate from the pinback, and this is because I think that the moment you say low versus high, you're implying that it's a grade. Because quality by definition, if quality is the fulfillment of the requirements, that's only a pass or fail. So in engineering, and this kind of goes to my wife is a chemical engineer, and she used to work for a company called Dow Chemical, producing polymers.
Just
and they
a small company.
Small company. They produce. She was a run plant, so her job was to sort of oversee the process that produced various grades of polymers. And so they had different levels, and any product could be like in spec or out of spec for given specifications. So she might have one run of that polymer, and it falls into a particular grade, and so they can sell it as this particular grade, and it'd be in spec for that. But another customer needs a higher grade, and so it's out of spec for that customer's requirements. And so the only thing that engineers care about, in the sense of I need to be able to use the polymer the polymer product in whatever I'm doing, is what grade do I require, and does this polymer meet that? Is it inside of that specification, or is it outside of that specification? If I need a nail, I need to know, does it meet the specification that is required for this application, or does it more? And if I have a nail that is over specified and it costs extra, then that's useless to me, because over specification doesn't give me any value in whatever I'm producing. And so there's specification and quality, or meeting those requirements, is purely a pass fail. And so there's no notion of a low quality or a high quality. It's just you either in spec or you're out of spec. And I think we would do well in software development to sort of think of our software, our product requirements, and whether the software is meeting that in those sort of terms. Are they meeting? Are they in specifications, or are they out of specification?
And again, I think that works if we go through the exercise of defining all of the requirements, whether they be functional requirements or non-functional requirements, whether they be the data must be saved to the database. When I click this button, it saves this form, or whether it be page loads must be sub-second page loads.
So what you're saying is this doesn't work.
In an ideal scenario, we would have all of those requirements sussed out, or at least spend the time as we were fleshing them out during sprint planning or during the writing of the software. Then we could make sure that we are committing to those and identifying those and delivering those.
So I think that if we're not doing that, then we don't necessarily have a. I think that we can sort of say, oh, there's too much burden here to get everything defined, and I don't know that everything absolutely needs to be defined. But I think that if we're not defining everything, or if we're not defining things sufficiently enough already, then how do we know when we've actually produced something, when we've actually met what the goal was, right?
Right. But if we don't define that, then someone's going to make the argument that we're focusing on items that have no value or don't necessarily or aren't necessarily required.
That's true. So I guess the second thing about the chemical engineering is, while they do define everything by their products, and ultimately what their customer cares about is what quality of product am I getting. Lots of different chemical companies go through various processes to get those products. So even though the product itself is specified, the process itself can vary dramatically. And some companies, being less scrupulous and cutting many corners, as long as the products come out, that maybe the user doesn't care, because it really isn't affecting the user as long as the product is inside of the spec that's specified. However, that being said, there are the processes matter for the profitability and the sustainability for the company itself. And additionally, they matter for the people that are depending on the companies getting those products and getting them properly in a properly specified form. So companies actually go through the process of actually getting ISO standards or ISO certifications for their processes that they're using, to say, look, we've gone through a review to ensure that we're in fact doing correct testing, and that when we say we're going to be able to deliver this product, our process guarantees that we're going to be able to deliver this product. And I think that's sort of one thing that we don't separate in software development, sort of lump everything up into one, and we say, well, is the process that we're following to write the software, right? Is that actually going to be able to produce the quality product? Even if we define or don't define the product requirements, does the process have any bearing on that?
Yeah, and that goes back to the conversation we had when we had Uncle Bob on a number of months ago, that as software developers, do we need a governing body? Do we need more organizations or an organization to be that governing body for software developers? Because just adhering to ISO certification or something like that, while some industries require that of software developers and software products, not all do. And not all software development is done in the same manner, and not all metrics are covered amongst the various industries, right? So do we need some kind of agreement on what quality is, on what grade is, on what the basic set of features and requirements for software is?
I think for the process, absolutely. I think that's even probably more necessary than the product.
So you mentioned source code and product and delivering of quality products versus code. I mean, is it that we're conflating source code and product and deliverable with the underlying structure of the code?
Yeah, I think so. I think and this is sort of coming back to, I think that there are two pieces that need to be specified. We first need to be able to make sure that the software specifications, like the product that we're actually delivering, and the functionality that's going out to the customer, can be written from the customer's perspective, so that we can say, hey, we all agree that when the customer wants to create this entry, that maybe we don't say it saves to the database, but maybe we say it needs to be persistent, right? So whatever it takes to get that to persistent, maybe that's a valuable solution. But we need to, in the end, have a solution that has a persistent, persistent setting that is available. On the flip side, we need to also be able to have the conversations with the companies that are creating the software, in order for the software, our companies to remain viable and to remain remain sort of creating software that is maintainable, that can be changed, that doesn't balloon as we create it. We need to be able to understanding that, hey, we should all follow these same standards and procedures, and to some degree we already kind of do that. And a lot of we talk about like internal standards and internal, like, following the structures. A lot of people would put in like peer reviews to say, hey, are we following the teams? This is what the team's practices are. Are we following those things? So a lot of this isn't something that we aren't necessarily doing. It's just, it oftentimes gets forgotten about, especially from the business perspective. So like from the developer side, we will maybe talk about peer reviews. We'll talk about trying to follow best practices, but then how does the business see those practices? Do they see those things as the developers guarding the business, or do they see them as just simply tacking on additional work and gold plating to a product that is extra and extraneous? So part of talking about this is saying, what is their perspective, and how do we look at this? And I think that's where I felt like if we broke these things into two different pieces, there's a software product requirement and there's a software process requirement. And from a software development perspective, we need to be able to have both.
So what would be an example of a software product requirement versus a process requirement?
So a product requirement might be the user needs to be able to log on, and they need to be able to enter their name, and it needs to be able to remember who they are when they log on again. Like, that would be a product requirement. A software process requirement might be like, we need to be able to have a way of testing, right? So we may say that some sort of test needs to be able to and again, I don't know about how these might be written or if there's a way to do that, but we might say, well, anytime we create a feature, we need to be able to have a set of tests or a test that covers that feature, right?
And you had mentioned gold plating, and I've relayed the story before that a consultant group that I was working with, I was trying to introduce unit testing and test-driven development to the team, and they had mentioned that they had tried putting unit tests and testing projects on the line item for their clients before, and the clients just vetoed it and removed that line item so that they could save that money. So we need to do a better job about fighting for the things that we see as necessary to do a good job, such as unit tests and logging and identifying potential failure points.
Mm-hmm.
I think we traditionally, developers do a pretty terrible job of explaining the business value achieved through the practices that we feel strongly about. We don't even explain them well to ourselves. So
yeah, and I think we need to get better at that. So I kind of looked at some definitions, trying to use the terminology that we had looked at before, and I thought, gold plating, we could maybe say gold plating is simply meeting additional software product requirements that are not in scope. And so, whereas like gold plating is not following architectural or development choices that ensure proper software process requirements. So that is a delineation that we need to find a way to make, and we need to find a way to say, look, as a business, we all agreed this is the level of process and the level of quality that we want to put into our process. And the business and the development get all on the same page and say, yes, we're committing to that. That way doing logging or doing test-driven development or doing something, we going into those products, we know that's already baked in.
So just upfront deciding this is the development process for this team, for this company, for this product.
For this product, whatever. Yeah, I think so. And then we do need to stop gold plating. I think there is some real, and maybe it's not everyone, but I think there is some real, developers trying to like go, oh, I think we're going to need this eventually, or trying to go ahead and build for things that aren't a part of the scope. And it's like, well, this would be really awesome, or this would be really sweet, and that only hinders the message that we actually want to do, because not only does it burn hours and burn money that could be going to actually producing the product that's needed to be created, but it sort of burns the bridge to the business, and it removes our ability to sort of leverage. Hey, no, we're only doing things that are making sure this product is and the software is going to stay afloat and is giving it a firm foundation.
Yeah, Agni, you ain't gonna need it.
Yep.
Yeah, there's also a danger too that a lot of developers and probably myself included in the past will try to implement something because it's the neat new shiny thing, right? I want to solve this with SignalR, or I want to use Node for this when there really is no business justification for using those technologies.
But it's fun.
It is fun if you can make the business case and it is a proper use of those technologies, then by all means. But like Ash said, if you go down that road and it ends badly, then you've burned that bridge.
Mm-hmm. Yeah, they'll never let you try out new shiny ever again.
I mean, I think sometimes there's projects that are really optimal for experimentation and that sort of thing. So it's just a matter of finding the right time. So another kind of piece that I think ties into this is the area of technical debt. And when I was looking at this, I felt like there really only should be two kinds of technical debt, but there's an unfortunate third, which makes up like 99% of all the other technical debt. But I digress. So when I was looking at this, I felt like there should be two. The one is intentional, and the other one is discovered. So intentional technical debt is when you choose to leave a software process requirement unfulfilled in order to fulfill a product requirement more quickly or more cheaply or whatever, right? So we're robbing Peter to pay Paul. We're sacrificing process in order to get a gain in the product. And what any technical debt, it's a lot like real debt. While it exists, it costs interest. So it's going to, as long as it exists, it's going to continue requiring payment. And sort of where technical debt snowballs is when we don't pay it off and people go, hey, we have this new item that we want to make, and it's going to cost whatever it costs to take that, but it's also going to cost the interest of the things that we didn't, the technical debt that we have. So we're going to have to pay to make that change, the cost of the change plus the interest of our previous technical debt. And the problem is that the business didn't like the cost of the change previously, which is why we have the technical debt. And so they go, well, hey, we found a way to escape having cost. And so therefore now we'll escape again. And the technical debt increases because we try to look for technical debt to reduce that cost. And all it does is it creates a bigger interest rate for us to pay the next time we go to make that change. So intentional is good, or it's neither good nor bad. It could be used as good in a specific situation, but we have to know, hey, this is what we're going in for. The other one is discovered, and they both have the same effect, but discover is the fulfillment, when the fulfillment of the specifications of the software process or product requirements basically create additional burden in order to fill a new software product requirement. So basically, we didn't foresee something coming. A perfect example, not in software, but in the chemical engineering example, they would have to run new pipelines. And so, you put in a pipe and then you put in another pipe and you look, whatever you're going to put in a new thing, and you're like, okay, am I going to affect what is currently existing? And you say, no, we're not going to affect that. And then you run it. And then 3 months later, you realize, oh, wait a second, we have to do maintenance on this third one because we need to intersect a T-joint. And now we can't intersect that T-joint because we just ran a whole new pipe and that's in the way, right? So that was something, a sort of discovered technical debt. We made a decision, and according to our processes, we followed the best processes that we could in order to, alleviate any sort of discovered debt. But unfortunately, it's going to happen. We're going to sometimes paint ourselves into a corner and find that we've increased the burden to make a change. And so
intentional debt is taking out a short-term loan to get past payday. And then discovered technical debt would be an unexpected bill comes due.
Yep, absolutely. Both have the same effect while they're left unpaid. And then the third sort of type that should never exist but unfortunately does is the unintentional. And this is really when you have poor fulfillment of the software process requirements, either because of a lack of understanding or specification or just plain negligence. And unfortunately, this is where I think a lot of places are. Hopefully that's being reduced as we go. But if you don't know what you're doing and you're not following good processes, then you're going to end up creating a lot of discovered technical debt, because you're going around sort of oblivious about all the bad choices that you're making, or you don't have we haven't actually thought about what are the requirements for having a good software process, and so therefore we just sort of willy-nilly put things together, and then all of a sudden we show up and go, oh wait a second, we're in a hole. How did we get here? So
yeah, we threw code into an editor and shipped it, and now we can't implement any new features.
Right.
Yeah, Doc Norton has a set of videos on Uncle Bob's Clean Code Videos series regarding technical debt, and I believe he has these three, but he places them in some subcategorizations also. He has responsible debt and irresponsible debt.
I like that.
So and all three of those could be either one. The one where you were saying we were just throwing code in willy-nilly and we didn't pay attention, and now we've got debt that it's either unintentional or we've discovered it. Well, that's irresponsible because you were just throwing code in. Whereas you could be writing code to the best of your knowledge, but turns out 3 months from now that the pattern that you were using was a terrible idea.
Sure.
Which, I mean, so between gold plating and technical debt, right? So the discovered technical debt and the unintentional technical debt could both be caused by trying to avoid gold plating. I know that my preferred method for writing software is growing the software. So write the best, smallest amount of code that you can write to meet the requirements today, and leave it flexible enough that it could be changed when the requirements are updated. But if your whole team isn't on board with that, then you will write code that is wildly inefficient for the needs that will be put upon it, and they will copy-paste your pattern everywhere and not update it to meet those needs. And then the next thing you know, you have a big ball of mud. What do you guys think would be steps to solve that problem?
I think having a good team consensus and maybe a project-wide definition of how software is written would go a long way. And as people grow and learn, and the software grows in complexity and becomes more feature rich, I think more eyes need to be in more parts of the code. So, I really want to see on pull requests, I want to see multiple approvers. I want to see multiple people giving feedback, because that allows for more eyes on the code in question and hopefully improves that code. But it also puts more eyes on that particular code that wouldn't necessarily have seen it. So I want everyone on the same page, or within reason, to be on the same page and have a reasonable expectation that everyone is traveling that same road and on the same path.
Yeah, it seems reasonable.
And what do you do when 90% of the developers are contractors from a third-party company that you have no control over?
Well, hopefully written into that contract, or whoever is the liaison between that consultant group, hopefully they can define the coding standards and the requirements of that team, and put in place those standards and that documentation, and say, this is how we develop software, and these are our expectations, and we're not going to accept lesser quality or lesser grade.
I think it's lesser quality. Yeah, it's that quality of process.
And we want to hear from you, dear listener. Let us know what you think. Leave us a comment on the podcast episode, or leave us a review on iTunes.
Oh, that's mine.
Go for it.
If you like this episode, then you should definitely go and like and rate and review on iTunes. But also, in the future, you should check out our Twitch and YouTube channels, which we are now live streaming to. They're both Six Figure Dev.
And find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.